Good morning, all. I think we'll just jump in. I'm not sure exactly how late the delay is right here, so I guess without further ado, we'll hop in. My name is Erickson. I'm the Chief Data Officer at Hennepin County, and we're here today to share our experience when we're actually our first use case of using graphs, and I believe we're actually the only local government entity in Minnesota, maybe even that I'm aware of, that's using graphs. So we're excited to kind of share our first steps into this and extend. There's a lot more we're hoping to do, but we'll share our experience this morning, and I'll let Alex introduce himself.
I'm Alex Long, data engineer for the county, and yeah, was involved with implementing the graph from the beginning.
So I like to move around a little bit, but I'll try to stay away from the screen. So just to give a little context setting for those who don't know Minnesota well, Hennepin County is Minnesota's largest county, home to Minneapolis, kind of right in the greater metro area. We're the largest county in the state, not by geography, but by population, the 34th most populous in the country. The county has about 9,000 employees, so we're like a mid-sized organization, so still pretty big. And then there's about 1.5, almost 1.3 million residents in the county. Because this is about the pandemic recovery, I also think it's probably good to give a little context on the way public health entities are set up in Minnesota, because they vary state to state. So we have ultimately a state and local partnership model. So there is a state public health entity, county public health entities, and then some large cities also have their own public health entities. And so there's collaboration between all of those levels with an emphasis on local delivery. So for example, even within Hennepin County, we have our own public health entity that's responsible for things like the COVID response. The city of Minneapolis, because they're so large, also has a public health entity, so we collaborate with them. So there's a unique structure there. A little background for us, at least in Hennepin County, March 12th was the first confirmed case that we had. And then the day after that, we activated an emergency response. And then actually that kind of blew up pretty quickly because this pandemic was unlike any other that we've had. We've had measles outbreaks, things like that in the past that have used a traditional response. And really very quickly, as of in April, myself and two other analysts were tasked to build a data response. And so we built, I would say, even by May, we had our first iterations of what we would call like our pandemic response dashboards or data capabilities. These are just two examples here that we built. This was kind of our daily sit reps, things that we built for the public. Actually really proud of this work that three analysts built a lot with this. And we were recognized by the National Association of County Organizations for it as well, so a little feather in our cap there. But this was all really focused on our day-to-day activities. So it was monitoring case volumes, things like that, but then really focused on the different activities the county was doing, what we were doing with vaccines, what we were doing with PPE, what we were doing with other mitigation strategies, whatever it might be. So really like our day-to-day efforts. And I think we did a really good job with that. If we go to the next slide. The one big gap we had, though, was beyond the data we had on COVID rates, things like that itself, was the bigger impact. Obviously, this pandemic was like none other that certainly I think most of us have probably experienced. It impacted everything. It impacted transportation, it impacted the economy, housing, so many factors. And for most of this, we're really flying blind. Most of the indicators we have about how the economy is changing, how the housing market's changing, at least in government, we're relying on official statistics from the Census Bureau, things like the American Community Survey, which are typically only published once a year, and even that have a lag. So we at that point said, okay, how can we do better? We know there's all these other data points out there. There's a Fun Economist article that we quote there that talked about that, the pros and cons of these as well. That might give us a lot more real-time insights into what's happening in the community and what actually are the things that the county should be aware of that we just maybe aren't even on our radar, right? Or we're hearing from anecdotes and don't have really good insights into what's changing.
Yeah. So at the very start, and as Eric mentioned, traditionally we rely on these old school methods of data collection. The census is the big one. They actually, not just the decennial, but they do a survey every year. But that comes out once a year, and even when it comes out on a lag. Now I think it's behind by like 2 years because of the pandemic, and then the decennial census had some issues too. And so the first step of this whole process was to take a step back and look for what are these non-traditional data sources that we know are out there, but what can we collect? And so we did this literature review of this space, everything that we knew that we possibly could get, like, oh, this seems like it could be related, and pulled those all together just into a big list, a big spreadsheet. Things like Google search trends, open table reservations, cell phone data, things like that. A lot of these are publicly available and so anonymized. And we also looked at a few internal data sources, but those have their own collection issues, and we wanted this to be something that everyone in the county could access, or the employees of the county at least could access to help inform their response to the pandemic as well. So we really focus on those publicly available data, pulling those together, and then the next question is, how can we make all of those constituent parts be equal to or greater than the sum? How can we make the sum be greater than the whole? Or whole greater than the sum? Backwards. A couple of those particular data points. The Zillow Home Value Index is a good public available data set. They also have Rental Index that's not on this list, but it's very similar. That is a smoothed map. They publish from their data sources, which they have a lot of housing listings, a smoothed index of what the housing price is in an area. That's available monthly on a 1-month lag at the neighborhood level, which is kind of an interesting geographical concept to both identify and aggregate. If anyone wants to nerd out about the GIS aspects after this. Affinity is a company that publishes credit card spending data, again, anonymized or aggregated. That comes out weekly, but on a 2-week lag. And that's at the county level, so a bit higher up than the neighborhood level. And the Bureau of Transportation Statistics, just another example, because it's yet another different time geography. That one's daily. It comes out on a daily lag, but it's only available at the county level, so you can't drill down any farther into that data. So lots of different data sources. Difficulty, question again, how do we combine those all to make sense of it on a comprehensive whole level?
Yeah, I think that's really, this problem, we're bringing this effort together, there's kind of multiple layers to this challenge, right? Like maybe at the highest level, it's still like, how do we summarize, make sense of this, right? And like a layer below that, right, and another layer below that. But the foundational was, like, how can we actually meaningfully integrate these? And this kind of goes to the keynote this morning, right, is that often we're storing data, and when we could do this in a relational database, we could store it in a lot of different ways. But typically, that means we're going to throw away all the inherent relationships about how those data points are connected. And the last thing that Alex and I wanted to do is we didn't want to build something that was only for us. We wanted to make sure that whatever we built could be reused. And it actually is interesting, when we first launched this project, with our executive committee, they were all on board, so this is great. But the main comment was, well, why don't we have this all the time? Like, why isn't this is something we should have beyond the pandemic, right? This kind of awareness would be helpful, on just day-to-day operations ongoing. So when we built this, we said, okay, we need to build this so it can persist and that other people can pick it up. So how do we do that? How do we stitch these different data points together, different granularities, different frequencies, different geographies, and do it in a way that can be easily reused by analysts beyond just my small team?
As Eric mentioned, this is response to the pandemic, but we kind of already had this idea in the back of our heads. We were thinking about graph databases even before the pandemic hit. In those, if anyone remembers, those few months run up where everything felt kind of impending, because we knew it was going to hit. And we had this idea that we have all these disconnected data sets. Some of them are public, some of them are private. Can we combine them? And the graph seems like that might be a good way to do it. And so to do our due diligence, we wanted to pilot a couple different options. So we did look at Cosmos DB. We're a Microsoft shop, as most government entities are, and Cosmos DB was integrated into Azure. We looked at that, the Gremlin, it was using Gremlin at the time. We looked at TigerGraph, and we looked at Neo4j. And we actually looked at those internally, and we also partnered with the University of Minnesota's School of Business Carlson Analytics Lab. They helped us out they actually did a really interesting project. There's a full 40-deck slideshow that I could show you about everything that they explored. And they were using Neo4j. And one of the things they did was using census data and then some other internal data as well to look at the locality of food shelves to where people lived to try to identify food deserts. And that's a screenshot from one of their presentations. So based off of that and also some of the research that we did internally, Neo4j was seeming like a promising solution. Even before the pandemic hit, we kind of already had that idea in our heads.
Awesome. I also want to just, would be remiss if we didn't give a quick shout out to a company called Internuntius. They're a consulting firm that's based in Minnesota. They helped us also in this first pilot really get us up and running with graph databases and do some of that evaluation. One of the other features that we wanted to make sure we have, and this is actually bigger than just graph and bigger than for a number of factors, but most of our reporting, and maybe this is just kind of an evolution that many organizations have, is that the analytics teams are often really frustrated because we create all these reports and then nobody uses them. I don't know if anybody else experiences that. So in general, we've been moving to say like, okay, there's a problem there, right? We're not doing this in partnership. We have to create a feedback loop and a dialogue in that. So then every report that we're creating, we're really trying to build in our process. This is going to be inherently iterative. And we need to get quick drafts in front of people and feedback. So this project was no different. We said like, okay, we need something that's going to allow us to do, and we wanted this because it's the response, very rapid. So we did 2-week iterations. So every 2 weeks we had some new addition, whether that's to the underlying data structure, whether that was to the dashboard we created. We wanted to make sure we could do that. So that was the other thing that graphs was really appealing, is like, oh, this seems like a technology that can do that versus a traditional relational database structure. And that whole feedback process obviously is then critical. The other thing we knew in this space, because all these non-traditional indicators, is that they were coming and going, right? And through the life of the project, right, we started with some data points. SafeGraph was a data set we were looking at, if anybody's heard from them. They do a lot of anonymized cell phone data as well. We're getting some of their data, then they dropped off. Other data sets were being published, then they stopped being published, right? Or we'd look at one and like, the quality is just, we have no idea, like let's drop that. So we knew this project was gonna cycle through a lot of different indicators, and we had to have a structure that enabled us to do that iterative process. So we'll kind of jump now to the final product, at least show you the end result that our business customers use, or our administrators and leaders look at. And then we'll jump into kind of our key lessons learned, and hopefully we'll be good on time here for a few questions at the end. What you're seeing here is 2 different screenshots from the ultimate dashboard that we have. The one that's a little more hidden on the left is kind of the initial page, where for each, we organize these indicators by domains. So we had like our housing domain, employment and economic activity, transportation, et cetera. And then we created a summary measure, an index for each of those to try to give the overall sense of how things were changing. And then for each different domain, you can go to that, you can see all of the individual level indicators that we have, plus then our summary measure. We definitely still consider this a work in progress for a number of reasons, and we can talk more about that. One, just because the index method is really, like how you create a good, meaningful index is hard. There's no really one right way to do it. We had a lot of great conversations with our colleagues at the Federal Reserve Bank in Minneapolis. Actually, they're pretty excited about this, or I'd like to think they're excited about it. That's what they told us, at least. Hopefully they're not just being nice. But this was where we're at in the final iteration. And we continue to develop this today. We're not on 2-week cycles just because there's not the same urgency. But now we're about a month, or every other month, we're releasing a new update to this, and with planned updates this summer on revisions to the indices, and again, some new metrics that we're bringing in, especially in our health domain and education domains. So it's an ongoing kind of living effort behind that.
Yeah. And this is the first live dashboard. We have lots of dashboards at the county. But the first one that's fully supported by Neo4j or any graph database in the back end.
Yeah.
So that was what we did in a bit of retrospective, that as the pandemic wore on, I'll just read it. The graph helped us fulfill the 2 key duties. The first is to interpret complex data. The second is to react to a changing situation, which Erik kind of alluded to earlier. For the first, interpreting this context data, and I don't think this is something we fully appreciated before we really got our hands dirty with the graph, but having the storage model be parallel to the logical model actually really helps to communicate like what it is we're building and what this data actually means to people who don't really know anything about databases or don't really care to know. But they think this is how they conceptually think about all these different indicators grouped together by domain is the color there, and then at the bottom there's a date or date tree, and then at the top there's geography. And that's how they think of like, yeah, this, so I want to be able to roll this up by something low level, like a neighborhood or a census tract, or maybe I want to aggregate all of these indicators together at the county level or at the city level. And maybe I want to do that by month, maybe I want to do that by day. I don't want to know about which indicator is being published daily or if it's on a 2-week lag or all that stuff. The logical model of the graph, or storage model of the graph, makes the logical model a lot easier to communicate to those business stakeholders, which makes it easier for them to use at the end.
And then building off this idea of changing to or reacting to a changing situation, I think you all probably hopefully know the benefits of being schemaless, and I just say in practice this really, really works. The other thing, actually, another point I really appreciated from the keynote today was Neo4j's idea about being, and I'm going to forget the phrase, but kind of best in category, right? Like they want to promote graph database as a solution to make this. And actually one of the, I think, the really rewarding things about moving into the graph space is that even in the Twin Cities, we're home to a really robust analytics community. There's a great organization called Mini Analytics that puts on biannual conferences. And I actually have to give Dan McCreary, who's at Optum, a lot of credit for introducing to graph. And I think he would even consider himself a graph evangelist, whether it's Tiger Graph that they're using or Neo4j or whatever. And there was a great group of people when we first started that says, hey, look at this, right? This is what it enables you to do. And actually, I'll give Dan credit for this because he always likes to describe it as the Jenga problem, right? And so when we're building a data structure, it's like we know, especially when we know things are going to change, we're going to add new things, we're going to pull blocks off. How do we make sure the whole thing doesn't collapse, right? And that's, I think, one of the critical benefits we found with graph is that we live this, right? There are indicators that have dropped off that we fully pulled out. It didn't kill our dashboard. Everything still worked, right? We've added new ones in. We didn't have to recreate an entire schema. And we could do that like within a 2-week cycle, right? Or there's days where we publish like, we're planning to publish an update to the dashboard on Friday. We put new indicators in the graph on Thursday and have those new indicators in the updated dashboard. So like a 24-hour turnaround for some new data points at times. Like that's something we've never would have been able to do before. So this like ability to react and adapt very quickly to how things are changing has been just one of the benefits that I think we can't emphasize enough that we've really experienced. And it's exciting to think about where we go from here. Like this, we definitely don't consider this project the finish line. This is like our first steps into this, and we're really excited about it. But we'll keep building from there.
Absolutely. So we've got time. I'm looking at the time. I think we maybe have flown through this, but we're going to leave some time at the end for questions as well. But I could spend a day talking about this slide. I'll try to keep it brief. The tech stack is actually, we started off very, very simple. Started up a database, went into it, and wrote some Cypher queries to APOC import from a CSV. Well, so the actual data collection and everything happened outside of the database, happened in Python scripts mostly. And actually still does, but we've gotten to the point where a lot of those scripts are running on-prem. At least they used to run on the server that Neo4j runs on. Now they run off the server inside of our county network, and soon in the process of migrating them all up to the cloud, which is kind of our strategy for a lot of our data pipelines and everything. Again, we're in Azure, but get to use a lot of the tools common to more mature data science projects, Databricks, Azure Data Factory, and all of that good stuff. Spark connectors to Neo4j. Very excited about that for all of our big data needs. And yeah, that transition has not been seamless, but it's been very smooth. And I think it's worked really well for us. Especially just being able to start off with simple Python scripts, because that's something that we're familiar with. And then it's easy to say to IT, hey, look, it's just a Python script. It's just an application that runs. Click run on main, and it loads all the data into the database for you. And they're like, okay, well, yeah, I can just schedule that for you. So now we get to actually handle all the scheduling ourselves, moving up to Databricks, moving those things into more of an automated fashion, more of a hands-off fashion, and getting to the stage where we really just have this thing run. As Erik said, sometimes indicators we have to manually drop or add them, but that's just turning that little module on or off. Otherwise, it just keeps itself updated and allows that data to persist and be available for us. And I guess the thing that's not pictured here is that Power BI is on the far end of that. It's just calling Cypher queries directly against the database. Or any other query engine that you wanted to use, you could query it from your laptop if you wanted, and we do that for some things as well. So that's kind of where we're at and where our next step is. A little bit farther along, and tying back into our lessons learned, we have some next steps. So the first is how can we make better sense of the data in our graph? The Graph Data Science Library is something that we've started to explore. I'm going to shout out Nathan there for his help. Neo4j has been very helpful in getting us up and running with the Graph Data Science Library. But then we have a lot of data at the county that we're not utilizing maybe to the best extent that we could, at least not in the graph. The first is person records. The biggest challenge with those is they're all confidential or private, very sensitive data. So handling the best way, or figuring out the best way to handle that. But there's a huge opportunity there, especially when we start to talk about the relationship between people that the county serves, their location in the county, and the services that the county provides to them, which again is just, I keep hearing digital twins, and I'm not sure I really fully understand just like what it is besides a buzzword. But I think this is as close as you can get to that in the real world with actual people, actually where they live, and recreating them in a digital sense in the graph, being able to find out their activities, being able to serve them better. We also at the county have a lot of property information that persists across people. People come and go, they might leave the county, they might show up one day and move in, but the property persists. We have a lot of information about that, who's building what, where. That could also be integrated with, I didn't get to talk a lot about our geography tree, but in the graph we have a very minimal kind of geography tree that just is census tracts and neighborhoods and cities and things like that. We also have a whole different department that does GIS in Esri and ArcGIS and those tools. I think that the graph allows us to do a lot of what they can do. I won't claim that it's a reproduction of Esri because I know they spend a lot of money on their tooling as well, but this is everything that I think we need for, at least for aggregation, and a little bit of data science on geospatial data. And that's really powerful, being able to kind of just easily set that up on your own and then run a geospatial query, like do a nearest neighbors query on properties and see what census tracts are being underserved and what are the other properties that we can find out about those from publicly available sources and merge that into, or merge our more private records into those. So making better use of our internal data, I think, is a big next step for us. I'm excited about where it can go from there.
Yeah, and I think that's one of this ability to react and keep adding more and more, I think is one of the things that's so exciting to us, because now we feel like we have a pretty good product here. I will say, interestingly enough, our leaders are probably rightfully a little skeptical of some of these new indicators. Actually, the Economist article I referenced kind of really said, actually they made this great relationship to U2, which I thought was kind of funny, but traditional statistics are like U2. They're tried and tested, they're always going to be good, right? Where all these new ones are like new groups we're not quite sure about yet. And so I think it's definitely a long view project. I would even say, I will take some credit for kind of being our graph champion at the county. I'm the one who's been putting this forward, saying this is something here, but it's still new to everybody. Even our IT partners are kind of like, what is that? What are you guys doing, right? And I think a lot of the products we're producing, it's going to take time for them to bear fruit just because they're new, right? These are our new insights. We haven't used these before. There's lots of reasons to be skeptical. And so really taking a long view is a key part of that. But behind the scenes, what we can see is all of these extensions. If anybody hasn't heard of the Opportunity Atlas, this was a project done by the National Bureau of Economic Research, led by Raj Chetty, I think was the lead on this. But they integrated a lot of census characteristics about place, and then actually a lot of tax records and things like that, and we're predicting future income or future earnings of a particular kid growing up in any neighborhood. And the fascinating thing they could show is you could have two different families with similar characteristics. So a family of in one neighborhood and a family in the other neighborhood, very similar, almost identical, where 2 miles away, the predicted future earnings of one family was $10,000 more, right? Which is not an insignificant amount. And really the key insight is their place matters a lot, right? And the county, we're an interesting place. We do have a lot of data about the residents we're serving, but we also have really I don't want to say archaic data practices. They're there for good reasons to protect privacy, but it makes bringing all that data together really challenging. So for us to build a 360-degree view of everybody we're serving is actually not an easy feat. In fact, we can't really do it, right? Not in a day-to-day operational sense, because the data practices don't allow us to just bring all those data together. We've been doing a lot with de-identifying data, with stitching data together, but then anonymizing it, right? So that we can at least still find the summary insights, right, without using it for operational purposes. And I think this mix of bringing all the data we know about the people we're serving with the characteristics of the places they live, I see a ton of potential to lock all sorts of new insights. And the exciting thing is, there's just one data set after another. It's like, okay, great, we're going to bring in stats about who we're serving and what those patterns are like. And then we can bring in our property data, right, and how property values are changing, things like that. Oh, now we know where our locations are. Oh, now actually there's some additional GIS functions that we might bring in, right, so we can do more fine-grained spatial analysis. And then we might have a new data set, and we can keep just layering that in and adding more and more insights. So it's really exciting to see as we build this over the next 2 years, I'm amazed at how much we brought together in just a year period of time and how many times we've iterated on this, like where we'll be in 2 years. It's hard to know exactly what that end product will look like, but it's really exciting to think about what's possible. And I think graphs, the concept of a graph database is really what's enabling us to do this. But that's so far, that's our experience with it at least.